Okay, so the CAI Neural API, you've sent us the GitHub README for it, so clearly you're at least a little curious about it.
Yeah.
And I have to admit, seeing Pascal being used for deep learning definitely caught my eye. What is it about this API that has people talking?
Well, what I think is so interesting is that they actually chose Pascal in the first place. I mean, usually you see Python frameworks kind of dominating the deep learning world, but the README actually does a nice job explaining why that choice might just be a game changer, for developers.
Yeah, it's almost like finding one of those, vintage sports cars that could still outperform modern performance vehicles. Like, what's the secret sauce here?
Well, they highlight a couple of things. One is Pascal's readability,
Mhm.
which is really helpful when you're dealing with these kind of complex projects. And then there's the fact that it uses native code execution. So things can run way faster. And they actually claim that in some architectures, this API can even outperform, some of the major players out there.
Okay. Now that's impressive.
Yeah.
So they're not just keeping pace. In some cases, they're actually exceeding what's already out there.
Yeah, it's pretty intriguing, you know.
I'd love to see those benchmarks.
Yeah, the README doesn't really dive into the specifics of the benchmarks or anything, but just the fact that they are seeing that level of performance is really interesting. It definitely makes you want to run some comparisons.
Absolutely. But okay, so powerful language aside, what about the actual, like, nuts and bolts of neural networks? How does this API handle something like volumes, which I know are pretty essential in deep learning?
So think of volumes kind of like dynamic arrays, but on steroids, right? They're designed to handle the massive data sets that deep learning models need, and they're optimized for performance using AVX instructions.
Okay, so we're not talking about like your grandma's set of encyclopedias here. AVX instructions, though, can you break that down for me a little bit?
Yeah, so imagine your CPU as a team of workers instead of just like one person, right?
Yeah.
AVX instructions basically allow the CPU to process multiple pieces of data at the same time. So it's like that team working in parallel. And that means much faster training and processing times for you.
That makes perfect sense. Okay, so we've got these supercharged volumes for efficient data handling, but what about the building blocks of the networks themselves? The layers. I'm guessing this API has those covered.
Oh, it's not just covered. It's like a playground of neural network layers. They've got everything from the usual suspects, convolutional, dense, pooling layers, but they also have some pretty unique offerings as well.
And this is where I think things start to get really interesting for developers. What are some of those unique layers that really stand out?
Well, one interesting example is they have separable convolutions, and these are especially useful for anyone working with mobile net architectures because they can really cut down on computational costs without sacrificing too much in terms of accuracy.
So faster, more efficient AI-powered apps, especially on mobile, that's huge for developers targeting those platforms. What else do they got?
They also have something called trainable normalization layers, and these have the potential to actually speed up the training process itself.
Like, really?
Yeah, because the API is actually learning the optimal settings as it goes instead of you having to, fine-tune everything manually.
Okay, now that sounds like it could save a lot of time and headaches during development. I'm really curious to learn more about how those trainable normalization layers actually speed up the training process. Like, how do those trainable normalization layers actually make training go faster?
Well, it's kind of neat, actually. They essentially adapt, like, during the training process itself. So it's like having a self-tuning engine in your car that constantly optimizes itself for the best performance based on the road conditions. The API figures out the best settings for these layers as it goes, instead of relying on you to find those ideal settings manually, which can take a lot of trial and error.
Okay, that makes sense. Less manual tweaking, faster training.
Yeah.
Got it. So speaking of training, one of the things I've always found a little bit tricky with deep learning is managing data sets. Like, things can get really unwieldy, especially when you're dealing with these massive data sets. Does this API offer any solutions for that?
Yeah, absolutely. They've definitely put a lot of thought into dataset handling. Right out of the box, it has built-in support for some of the most common data sets like SafeR10, MNIMist, Fashion, all the usual suspects.
Yeah, those are great for, just getting started quickly or for those standard benchmarks. But what about if you're working with a custom data set, like for a specific project?
Right. They've got you covered there too, and they've made it surprisingly user-friendly.
Yeah.
So the API uses a really straightforward approach, what they call one class per folder for those custom data sets. So you basically just organize your images into folders, one folder per class, and the API pretty much takes care of the rest.
Okay, that is pretty slick. Keeps things nice and organized.
Yeah.
Okay, so let's say we've got our network built, our data's loaded, time for the real magic to happen. training. And this is traditionally where things can get really, really complicated, not to mention time-consuming, right? So what does the Readable say about the actual training process with this API?
Well, one thing that really jumps out is their focus on efficiency. So they offer a couple of different fitting methods like T-neural image fit, T-neural fit, and they're all designed to be pretty easy to use. So even if you're not a coding wizard, you should be able to get your training process up and running without too much hassle.
That's a relief to hear because, let's be honest, sometimes training a deep learning model can feel like watching paint dry.
Yeah.
And speaking of which, how does this API handle that speed issue?
Mhm.
Because I've heard horror stories of people waiting days, even weeks, for really complex models to train.
Yeah, no, they've definitely tackled that head on. The RIA-DME specifically mentions that they're using parallel computing to really speed things up. And they use something called neural thread.pas for that.
So instead of one chef painstakingly preparing your meal, you've got whole kitchen crew working in parallel.
Yeah, exactly. And that means if you have a multi-core processor, the API can really take advantage of those extra cores and dramatically reduce your training time. So it's a pretty big deal, especially if you're working with, limited computational resources or if you just want results faster.
Makes sense. Are there any other training features in the Reatom that caught your eye?
Yeah, actually, there's one more I wanted to mention. They actually have a really smart solution for when you're dealing with truly massive data sets, like data sets that are so big they might not even fit into your computer's RAM all at once.
Oh, wow. Okay. Yeah, that's a real problem for a lot of people.
It is. So they have something called T-neural data loading fit, which is specifically designed to handle those situations.
Okay, I'm intrigued. How does that work?
It basically loads and processes the data in chunks, so it makes it possible to train on these giant data sets that are way bigger than your available memory. And this is a huge deal, especially for researchers and developers working with, really massive data sets that might have required specialized hardware in the past.
Yeah, that's incredibly useful. So it really seems like no matter how big or small your data might be, this API has a solution ready to go.
Yeah, this API really does seem incredibly well-rounded. I mean, we've talked about its speed, the variety of layers, the way it handles data, that really user-friendly approach to training. It's like they thought of everything.
Well, and we haven't even touched on one of the most interesting things the Readable mentions.
Right.
We've been focusing mainly on image classification here, but this API also has applications in natural language processing, NLP. Oh, wow. Okay, so now we're talking about things like text generation, sentiment analysis, all that good stuff. That opens up a whole new world of possibilities. It's amazing to think that a tool built on Pascal could be such a versatile player in the AI field.
I think it really speaks to, challenging those assumptions that we sometimes make about, which languages are best suited to certain tasks. It really shows the power of innovation and how it can come from some pretty unexpected places.
It's a good reminder that we shouldn't underestimate, the power of a well-designed tool regardless of the language it's built on. This CAI Neural API has definitely given us a lot to think about today.
It has. What stands out to you as the most compelling thing about it?
For me, it's that combination of performance and just how accessible it seems. I mean, they've
Yeah.
managed to create something that's both really powerful, but also relatively easy to use,
Mm,
which is a pretty rare find, honestly.
yeah, I would have to agree. It really lowers that barrier to entry, for developers who might have found deep learning a little bit intimidating in the past. But then at the same time, it offers, those features and that level of performance that's really going to appeal to seasoned practitioners as well.
Yeah. Well, if you're listening and your curiosity is piqued, I definitely recommend checking out the CAI Neural API's GitHub Readable for yourself. You might just find the inspiration for your next big AI project.
Absolutely. And if you do decide to take the plunge, let us know. We'd love to hear about your experiences. It's a really fascinating example of innovation in action.
It really is. And with that, we'll wrap up our deep dives into the CAI Neural API. Until next time, keep exploring and happy coding.